us have a look with the first questions of your tutorial. Okay. Okay, so these are the two questions from question 1. And since the questions involve the triangles, and the triangles are all right angle triangle, okay? So that's why we can actually solve this just by using the ratio of the trigonometry, okay? Right? Okay, hold on now, 1 minute. Okay, so normally I will open my phone to see your message. Okay, so for the, for example, how we actually solve for the questions number 1, I'm not sure whether you can see it clear. The x1 and x2 is quite small. Okay, okay. So for the questions 1a, right? Okay. Yeah. Can I have any students unmute the mic and let me know that you can see my screen clearly and can hear me clear?
Yes, we can hear and see clearly, Miss.
Okay,
Yeah,
thank you very
can
much.
hear and see.
Okay, thanks. Okay, so for here is actually x1, and the values here is actually x2. Okay, here is x2. This one is x1. Okay, then you have angle 19.2, right? And 27.3. So here and also here. Okay, now can we able to use the angles here to find the x1? Okay, okay. So if we refer to the angles that we have, right, 27.3. So the hypotenuse is 12.7. Then we have x1, right? Okay. So what is the trigo that is involved, the adjacent and also the hypotenuse? Okay. So if you look at part A, I give one example. Okay. So adjacent over the hypotenuse, okay, that is referring to the cosine, right? So cosine of 27.3, it is actually equals to x1 over 12.7, right? Okay, so from here, then we can solve for x1, which is 12.7 times cos 27.3, right? Okay, so let me check the answer. Can I have students to give me the answer for the x1? Any one of you? $11.55. Okay, hold on. I don't think I get 11 point. Okay, 11.29. Yes, okay. I get 11.29. Okay? Yep. Okay. So x1 should be 11.29 cm. Okay? Okay. Now, can I have x2? Okay, x2. How we actually find x2? The x2 here. Okay? Can I have students to tell me how to find? Okay, maybe I start from the bottom. Okay, Ching, how we actually find the x2? Can you give me the steps?
Yeah, you can use the sine
Sine
of 19.2
equals to
x2 over 11.29 cm.
Oh, okay, which is the x1 that we just obtained, right? Okay.
Yeah,
okay.
correct.
Okay, so x1 that we just obtained as 11.29, then sine 19.2. So we can solve for the x2, which is 11.29 times sine 19.2. So what is the answer? Cheng Hao?
3.713 cm.
Okay, 3.713 cm. Okay, we can correct to 2 decimal places, say 3.71 cm. Okay, yep, correct. Okay, so now let's move on to part B. Okay, for the triangles for B, we use the similar way to actually solve this. Then may I know how others solve for the questions? Okay, this one is x2, 3.71. Then let's move on to part B. Okay, how about B? Can I have another student? Okay, Kai Feng. Okay, how you solve for the x1? Kai Feng, are you here? This one you're not sure. Okay. Can I have another student? Sutesh?
Hi,
Any
Miss.
idea?
Yeah. Okay, so I used the angle 16.5. Okay, so I
Angle
took
16.5. Oh, you mean this angle, is it?
oh yeah, I found that.
You found this angle.
Yeah, so I took 90 degrees minus 73.5, 180 degrees minus 90 degrees minus 73.5,
Okay,
and I
which
get
is?
which is 16.5 degrees.
Okay, so that means Sutesh find the angle for 16.5. I think everyone know how to find this angle. Okay, then?
Then I used cos.
Okay, cos
Cos
of?
16.5 equals to 16.1
Mm,
over x2.
over
X1.
x1,
X1. Yeah.
over x1. Okay, thank you. Okay, so that means cosine of 16.5 will be the adjacent 16.1 divided by the hypotenuse x1. Okay, so by looking for the angle 16.5, then can find the x1. Okay, then the x1 will be equals to 16.1 divided by cos 16.5. Okay, 16.1 divided by cos 16.5. Okay, okay, so yeah, Kai Feng, can you understand now? Kai Feng, can you understand? Yes, sir. Okay. Okay, so what is the answer for x1?
16.7915.
16.7915. Okay, so let's say 2 decimal places, 16.79. Okay, thank you. Okay, now x1 done. Okay. Yes, any question? Come on, unmute the mic.
How 16.5 came? Can you explain it again, ma'am? Angle.
How to get 16.5, is it?
Yes, ma'am.
Okay, so okay, so can you see right now we are referring to, oh my God, okay. Okay, so right now we are referring to this triangle. Okay, so as we know for a triangle, the total degree inside the triangle, okay, is actually 180, right? 180. So we already have angle of 90, angle of 73.5. So we take 100. Sorry, I put the highlighter. Okay, so I take 180 degree minus 90 and minus 73.5. So I minus with this angle and this angle, so the rest will be this angle. So I get 16.5. Is that clear? Just now, who is asking?
Ma'am, why we minus from 180?
Sorry?
Why we have subtract from 180?
Why is 180, is it?
Yes, ma'am.
Okay, for any triangle, for any triangle, all the angles, right, when you add it up is 180. Okay, so for example, this is A, this is B, this is C. Okay, the three angles added up must be equals to 180 for triangle, must be 180 degree. Okay, so you need to remember this. Okay.
Thank you, ma'am.
Okay. Okay, so now let's move on to X2. Okay, can I have another student to tell me how to do X2? Samuel? Okay, how to do X2? Can you tell me? Samuel, are you here? Samuel?
Miss.
Okay.
But I can't give the answer, but I can give the working now because
Yes,
my
yes,
calculator not working.
Uh,
I'm trying to fix it.
Yeah, tell me the methods.
So yeah, give me a minute. Need to think. You take the tangent of the 42.6 equals
First
to
one.
x2 over x1, which is the given answer.
Okay, yeah, 16.79.
Then
Okay,
you
then,
rearrange. Yeah.
yeah, okay, correct. So the X1 we obtained from earlier part, 16.79. So we can find X2 as 16.79 times tangent 42.6. Okay, then we get the answer. Okay, so can I have Ziyi? What is the answer?
The answer is 15.44.
15.44, yes. Okay, thank you. Yeah, it's correct. So when you, okay, so most of the degree, the angle that we involve here is in degree. So when you find the tangent, cosine, and sine, you have to take note. Make sure the mode in your calculator you change to degree. Okay. So if let's say radian, then you have to change to radian. So you have to take note. If let's say you're using the mode for radian to calculate the degree, then definitely you will get the wrong answer. I saw some messages in the chat box. So need to be careful about that. Okay. And for those students, we need the calculator for these topics, okay? Else you can't solve it. So almost every topics we need to do calculation. Okay, so we're already done with the first question. Is that clear? Students, is that clear? We are just involved the sine, tangent, cos, okay? Okay. Okay, about the first question, is that clear? Any questions you want to ask? I would like to continue with the lecture. Clear? Okay, thanks for the feedback. Okay, then I will move on to the, continue what we have gone through. Okay, yesterday we stopped here, right? Okay, yeah, we stop it here. Then we continue with this question. Okay, so this is another problem, okay? And these problems, actually, we can also solve using the theorem of Pythagoras and the ratio of the trigonometry. Okay, so for point A, okay, lies at the coordinate of 2, 3. Okay, so A is at the coordinate of 2, 3. So A coordinate of 2, 3. So it's here. Okay, then the point B is at 8 and 7, another coordinate. So determine part A, the distance for AB and the gradient of the straight line of AB. Okay, so for the distance of AB, that means from here to here, okay, as already draw here. Okay, so this is the distance for AB. So you need to find the distance of AB. And from this AB, we can actually draw a right angle triangle. Okay, we can draw a right angle triangle. So let's say here we put a C, okay, to indicate ABC is a triangle. Okay, so how we actually solve for the AB? So by looking at the right angle triangle, this is a hypotenuse, right? So we can use the theorem of Pythagoras to solve it. So this is a hypotenuse, so we can solve by AB squared equals to AC squared plus BC squared. So how we actually know what is the length for BC and also for AC? So since this is in the coordinate system, then it will be very easy. So we can just read the values here. Okay, so how many units here? So here is 4, right? And then from 2 to 8, so here will be 6, right? So which is 6 square plus 4 square. So the square root of 52 is giving us 7.211, okay? So you can also write as 7.21, 2 decimal places, okay? Okay, so that's how we get AB, right? Okay, then the next, you asked to find the gradient of the straight line for AB. What is the gradient for AB? Can you still recall back how to find the gradient? So to find the gradient, right, okay, remember, it's actually the vertical height divided by the horizontal distance, right? Delta y over delta x. So the vertical height is actually 4. Okay, then the length here is actually 6. So which is 2 over 3. Or when we say delta y over delta x, it's actually same as a tangent of the theta. Okay? Okay, yes. Okay, as the students write it in the chat box. Yep, the gradient of m is actually y2 minus y1 divided by x2 minus x1. Okay? Yep, correct. Okay? Okay, so thanks. Okay, then for your participation, then we go to the next one. Okay, so for the next one, it's about the positive angle and also negative angle. Okay, so when come to angle, sometimes you can see the sign is positive, sometimes the sign can be negative. So what we can understand when there's a positive sign for the angle and the negative sign for the angle. So by referring to here, okay, as your recap as well. So if we have a positive angle, means the angle is measured from the positive x-axis in the counterclockwise direction. And for negative angle, that means the angle is measured from the positive x-axis in the clockwise direction. So what is the clockwise and counterclockwise? Okay, so if we look at the clockwise direction is follow the clock. So counterclockwise, we can say, we can also say it as anti-clockwise. Okay, anti-clockwise, which is opposite the direction of the clock. Okay, opposite of the direction of the clock. So what is means by the positive x-axis? So when we look at the axis system, so this is x, this is y. So positive of the x is actually here, right? So when come to x-axis, here is positive. So this is where we measure the angle, okay? So now let's look at the positive angle. So if we refer to the positive angle, so I draw it here, okay? So, okay, so as I say just now, we measure from this, right? So let's say we have an angle of positive 30. Okay, positive 30. So positive 30 means I measure from the positive x-axis. Okay, so 30 degree from the positive x-axis. Okay, 30 degree from the positive x-axis. Okay, so this is means by the positive angle. So how about other angles? So let's say we have positive 150. Okay, so that means again start from here until here. Just roughly, so this is 150. Okay, so and then let's say 190. Okay, so it might be up to here. Okay, 100, sorry. Let's say 200. Okay, so that's how we measure it. Okay, positive angle. So for negative angle, okay, is in the clockwise. Okay, clockwise. So let's say we have negative 30. Okay, so as I say, we measure start from this axis and follow the clockwise direction. That means will be here. This is negative 30 degree. Okay, so how about negative 150? Okay, so 150 already go to, it's already more than 90, but less than 180. So let's say somewhere here, from here to here, negative 150 degree. Okay, so let's say negative 200. Okay, so it's already more than 180. So that means it's here. Negative 200. Okay, students, can you understand the positive and negative angle? Yes, okay. So then I will continue, right? Okay, so next we will continue with the ratio of the trigonometry. Okay, so previously we already done the basic one, which is the sine, the cos, the tangent, and I think yesterday students shared with us saying that sine is actually SOH, and the cos is a what? CAH. Okay, then the T is TOA. Okay, yeah. So it looks quite interesting because last time I'm not using this way. Okay, we don't have this. Okay, so now we go further. Okay, sine, cos, tangent. Okay, so which is I think we refer to this triangle. Okay, this triangle. So for the opposite side, okay, if we say tangent A, right? This is tangent A. So BC over, okay, wait. Let me label it first. So since this is the angle for A, right? So the side we label it here. Here will be a small letter of A. So for C, right? If here is the angle for C, then the opposite side is the length. So we put small letter of C. Then for B, right? Here will be small letter of B. Okay, so that's how we label each side of the triangle. Okay, so like what given here, right? Okay, so the sine is actually A over C, cos is B over C, tangent A is A over B. Okay, so I think you should understand this one. Okay, now let's move on to cosecant of A. So still remember cosecant of A is actually a reciprocal of the sine, which is 1 over sine. Okay, 1 over sine, that is a cosecant. So if let's say sine is A over C, 1 over sine will be C over A. Okay, okay, then for secant A, okay, secant A is 1 over cos. Okay, 1 over cos. Okay, so for 1 over cos, okay, cos is B over C, secant, which is 1 over cos, will be C over B. Okay, C over B. Okay, next one for cotangent. Cotangent is actually 1 over tangent. Okay, so how I remember cotangent, okay, so because this is a T, so 1 over T. So secant, so 1 over cos. And the next one will be, can you see the S here? 1 over sine. So that's how I memorize. Okay, so maybe you can use the same way. Okay, then tangent is A over B, so cotangent will be B over A. Okay, so now there's another relationship between the sine, the cos, and tangent. So for tangent A, right, okay, for your recap, tangent A is actually equals to sine A over cos A. Okay, tangent is equals to sine over cos. So since tangent is equals to sine over cos, remember cotangent is actually 1 over tangent, right? Okay, 1 over tangent. So then the cotangent will be cos over sine. Okay, cos over sine. So this one upside down, right? Okay, so is that okay, right? And please take note the short form that we use for each trigo. So for sine, sin, cos, cos, tangent is tan. Then come to cosecant, CSC, okay, cosecant, CSC, secant, and cotangent. So for secant and cotangent, we take the first 3 letters. So actually for sine, cosine, and tangent, we also take the first 3 letters. Except the cosecant, we take CSC, okay? CSC for cosecant. Okay, so this is a recap. So is that okay so far? Just for you.
Hello, Miss.
Yeah.
Excuse me.
Hmm.
It's the first time for me to take the other formulas. So do we use them for the same purpose, for the right angle triangle only?
Sorry, I don't get what is your question.
My question is, when do we use these formulas, the other formulas, the constant
No.
and all of this thing? Yeah.
You mean the cosecant, secant, and cotangent, right?
Yeah, exactly. Yeah.
Okay, so okay, here we are just trying to introduce other trigonometric, okay, other than the basic of sine, cos, tangent. So here I introduce the cosecant. Just for your information, cosecant is actually the reciprocal of the sine, which is 1 over sine. So secant, which is 1 over cos, cotangent, which is 1 over tangent. Okay, so this is something further on trigonometric. Okay, then when in the future, when come to the trigonometric identity, so we are going to see these other trigonometric. And then this is another things that you need to understand, the relationship between the tangent, sine, and cos. Okay, so this is the basic knowledge that you need to have for trigo. So this is what I'm trying to tell you. Okay, and of course, if you understand this one, definitely you should understand this one as well. Okay?
Okay, Miss. Thank you.
It's a basic, huh? Okay, now let's move on to the next problem. Okay, given that the sine is 4 over 5 and cos is 3 over 5, and then tangent is 4 over 3. Okay, then you ask to find the cosecant, secant, and cotangent. Okay, so now for cosecant, right? Okay, as I say just now, cosecant is actually 1 over sine. So since the sine is already given as 4 over 5, so you substitute sine as 4 over 5, then your cosecant is 5 over 4. Okay, then come to secant, right? Secant, can you see is, as I say just now, you can refer to the last letter, right? It's a C. So it's 1 over cos. So the cos is 3 over 5. So 1 over 3 over 5, which is 5 over 3. Okay. Then for cotangent, can you see this is about T, 1 over tangent. Tangent is 4 over 3, which we get our answer is 3 over 4. Okay. Okay, so it's just a simple one. Is that okay so far? Can you understand how we get the value? Right? How we evaluate the cosecant, cotangent, and secant. Okay? Is that okay so far? Yes, huh? Okay, good. Okay, then we move on to other problems. Okay? Okay, so for the next questions here, we have sine beta, which is given as 6 over 7. So beta is an acute angle. Okay, now, any one of you know what is an acute angle? Anyone? Okay, so I have two answers here, below 45, below 90. Yes, okay, so which is the angle between 0 to 90. Okay, so less than 90, yes, below 90. Okay, that is the acute angle. Okay, so in other words, yeah, okay, between 0 to 90, below 90. Okay, Man Heng, very fast Google it and copy the definition. I'm sure this is not typed by you, right? Okay, yes, correct. Okay, so nowadays a lot of things we can just Google, right? Okay, acute angle is an angle less than 90. Okay, so this is information about our beta. Find the other 5 trigonometric function values of beta. Okay, so okay, now the other 5 trigonometry, that means the cos, cosine, then the tangent, followed by the cosecant, then secant, and cotangent. So these are the other 5 trigonometric that required. Okay. Okay. So how are we going to find for others? So we will get the information from the sine beta that we have. Okay. So as we know, sine beta is actually opposite over hypotenuse, right? Okay. Opposite over hypotenuse. So we draw a right angle triangle as what we can see right here. Okay. So this is beta. So opposite over hypotenuse. So we label it, okay? Then let's say we label this as a A, right? Okay. Then by using theorem of Pythagoras, right? Then we can actually find the length of the A, okay? Length of the A. So to find the length of the A square is actually equals to, okay, A square is actually equals to 7 square minus 6 square, the hypotenuse minus the 6 square, right? So we get 49 minus 36, which is 13. So A is square root of 13. Okay, A is square root of 13. Okay, now after we having the length for the side A square root of 13, then we can find the rest. So for the sine beta, which is opposite over hypotenuse, 6 over 7, right? Cos beta, which is the adjacent over the hypotenuse, square root of 13 over 7. Then for tangent is opposite over adjacent, which is 6 over square root of 13. Okay, so or we can express it as this one. Can you understand how we get to this answer? Okay, let me explain.
Square root 13 times square root 13.
Square root 13 times square
The
root.
bottom square root, I mean the whole thing multiplies square root 13.
Okay, so yeah, okay, 6 over square root of 13 times square root of 13 divided by square root of 13. Why we can multiply by this one? Because this whole thing is actually equals to 1. Okay, okay, then square root 13 times square root 13, the one at the bottom, it will give you 13. Then at the top, we have a square root of 13. So that's how we get the answer. Okay, thank you. Okay, so next one, for cosecant. So as we know, cosecant is actually equals to 1 over sine. 1 over sine. The sine is 6 over 7. So 1 over sine, which is 1 over 6 over 7, which your answer is 7 over 6. That means you upside down the values, okay, reciprocal. Okay, then second is actually 1 over cos. Okay, 1 over cos. So the cos is square root of 13 over 7. So it will be 7 over square root of 13. And again, using the same way just now, if we multiply by square root of 13 over square root of 13, I can also express this as 7 square root of 13 divided by 13. Okay, then come to cotangent. So tangent is 6 over square root of 13. Cotangent is actually square root of 13 over 6. Okay, so is that okay? So because this one is 1 over tangent, this one is 1 over cos. Okay, yes, okay. Okay, next one. We try to go through the trigonometric for some common angle, okay, which is a 45 degree. And we will also go through on the trigonometric for the 30 degree and 60 degree. So these are some common degree, okay. Now let's look at the right triangle, okay. So can you see this is an isosceles triangle because they have two sides which are the same. Can you see the values of 1 and 1? And when these two sides are the same, then with the 90 degree here, the another two angles must be the same. So which is 45 and 45. Okay, then by knowing the length of the two sides, so we can able to get using the theorem of Pythagoras to get square root of 2 for the hypotenuse. Okay, so this is the triangle, right? Okay, so now, okay, so what is the sine, cosine, and tangent for 45 degree? Okay, so for the sine of the 45, okay, is opposite over the hypotenuse, so which is 1 over square root of 2. So we can write the answers for sine over 45, sine 45 degree as 1 over square root of 2, or I can write it as square root of 2 divided by 2. Again, using the same concept. 1 over square root of 2, I can multiply by square root of 2 over square root of 2. Okay, which the bottom, square root of 2 times square root of 2, you get 2. At the top is square root of 2. So either you can write the answer as 1 over square root of 2 or square root of 2 over 2. Okay, so this is some common angle that we may need to know why sine 45 is actually giving us 1 over square root of 2, because sometimes we will express our answer as a third form. Okay, so when your answer is in square root, so we say insert form, right? Okay, so of course when we count as a decimal is 0.7071. Okay, then come to the cos of 45 is actually adjacent over hypotenuse, so it's also 1 over square root of 2. So for your information, sine 45 and cos 45, the values are the same. Okay, the values are always the same. Okay, then for sine 45, I think this is very common. We know sine 45, the values always equals to 1. Why? Okay, opposite over the adjacent is actually 1 over 1, which is 1. Okay, so this is something very important. Sine 45 is actually 1. So this is some common angle, okay, that we need to know. Okay, so after 45 degree, then we move on to the angle for 30 and 60. Okay, 30 and 60 degree. Okay, so now if we try to refer to a triangle with 3 equal sides. So that means all the 3 sides are the same. That means total degree is 180, right? Divided by 3, each angle will be 60 degree. Right, 60 degree. Okay, so if I okay, hold on. Samuel, here is about 45. Oh, okay. You are saying that common angle, of course, sine 90, cos 90, this is another common that we need to know as well. Okay, I'm not saying that it is not, yes, okay, but I'm just trying to tell you about sine 45 and cos 45, okay. As I say, because sometimes we will express our answer in the third form. Not all the not all the trigonometric for any angles you can put in the third form. Okay, but for 45 degree, we can put it in the third form. So here I'm trying to tell you in the third form, this is the value. Do you get it, Samuel?
Yes.
Okay, so now back to the question just now, another triangles for 3 equal sides. So 60 degree for each angle, right? So now let's say I split this into half, right? So that means it will be 30 here and another 30 here. So this is 90 and 90 degree, right? So this is what we just get this part, okay? Okay, now let's consider this triangle. Okay, we look at this triangle. Okay, so since just now we say we split into half. Okay, let's say we have equal sides, right? 2, 2, 2. This one also 2. So that means each one will be 1 and also 1. Okay. So now we have a 2 and 1. Then how about the side here? What is the height here? Okay. So again, because this is a right angle triangle, so we can use theorem of Pythagoras to solve it. So I won't explain in detail. So that means I managed to get a as square root of 3. Huh? So I think you all understand how to get square root of 3. Okay, so here is square root of 3. Okay, so now let's look at here. Sine 30 is actually opposite over the hypotenuse, which is 1 over 2. Okay, so this is something very common. Sine 30 is equals to half. Okay, and then how about cos 30? Cos 30 will be adjacent over hypotenuse, which is square root of 3 over 2. Okay, square root of 3 over 2, which is 0.8660. So in the third form, okay. Okay, then for tangent 30, so tangent 30 will be 1 over square root of 3. So can you see how we express the angle in third form? Of course, we can also write as square root of 3 over 3. Okay. Okay, then move on to sine 60. So sine 60 is actually square root of 3 over 2. Okay, you see the value in the third form. And do you realize that, okay, wait, this one I'll talk later. Okay, then sine 60 will be 1 over 2, so which is half. So do you realize that when come to cos 30 and sine 60, they are actually the same value. Then when come to sine 30 is half, right? Cos 60 is actually half, okay? The both also equals to half. Then for tangent 60, okay, then will be square root of 3 over 1, or we can write it as that means square root of 3. Okay, so this is how we express the sine, cosine, tangent for 30 and 60 degree in the third form. Okay, so is that clear? How we get the value? Because sometimes we will, for some of the value, we'll say, oh, this one sine 60 is square root of 3 over 2. So you understand how you get to this set. Okay, so this is a summary from the triangles that we go through just now. Okay. Okay, is that okay so far?
Yes, miss.
Yes, sir. Okay. This is a summary. Then we will continue. Okay, we continue with the angles of elevation and angles of depression. Okay, so let's understand what is means by the two terms here, elevation and depression. So why is so important? Because sometimes when come to some of the problems, so we will describe the problem saying that, oh, the angles of elevation is this, the angles of depression is this. So you need to understand what it means by angles of elevation and angles of depression. Okay, so for angles of elevation, okay, so let's look at the explanation here. Okay, let's say BC represents horizontal ground. Okay, horizontal ground. And then AB is a vertical flagpole. Okay, flagpole. And then the angle of elevation of the top of the flagpole. Okay, where is the top of the flagpole? Which is A. Okay, this one. This is the top of the flagpole. Okay, A. From the point C is the angle that the imaginary straight line AC must be raised or elevated from the horizontal CB, which is the angle of theta. Okay, so can you see this is angles for the C, right? Sorry. So this is your C, okay? So can you see this theta, okay? The theta that we just mentioned here, okay? So the theta that we just mentioned here is actually referring to angle of elevation, okay? Angle of elevation. Okay, so let's say I just put it, make it simple, okay? Make it simple. So imagine, okay, it's okay. I summarize this later. Okay, so that means the angles from the horizontal line to the top of the flagpole, okay, we call it as angles of elevation. Okay, it must be measured from the horizontal line. Okay, measure from horizontal line. Okay, then how about angles of depression? Okay, when come to angles of depression, right? So this is an example. PQ represent a vertical creep. So this one is a creep, right? Okay, this is a creep. Then there's a shape of the R. So this is a shape of R on the C. Then the angle of depression of the shape from point P, okay, from point P is the angle through which the imaginary of straight line PR must be lower or depressed from the horizontal to the shape, which is the angle of phi. Okay, so this angle is actually angles of depression. Okay, so remember the angle of depression must be measured from the horizontal line. Okay, so now let me, okay, let me summarize it about the angle of depression and angle of elevation. Okay, so let's say if I look at people, okay, so say this is the building. Okay, let's say this is a building. Okay, so this is how we look at the things, right? Okay, this is the top, this is the bottom. Okay, okay. So when we look up to the top of the building, right? Okay, so this angle is the angle of elevation, the one that we mentioned just now. Okay, and if the person is looked down to the bottom of the building, okay, can you see the angle is actually measured from the horizontal line? Okay, so this angle is an angle of depression. And the angle must be measured from the horizontal line. Okay, so look up, angle of elevation, look down, the angle of depression. So do you think you can understand? Is that okay?
Excuse me, miss. Can you repeat the angle of depression?
Okay, so when we look at the person here, okay, if the person look down to the bottom, okay, look down to the bottom of the building. Can you see this is the bottom of the building? Okay, then the angle from the horizontal line, this is a horizontal line, okay? We measure from the horizontal line, okay, towards the direction of the bottom of the building. So this angle, we call it as the, here, this angle is the angle of depression. Okay, this is angle of depression. Yeah.
Okay, thank you, Miss.
Okay.
Yes, it's okay. Thank you.
Okay, let me see. This one. Okay. Go through one more example before I give you the short break. Okay, this problem is about the angle of elevation. Okay, the terms that we go through just now, elevation or depression. Okay, so an electricity pylon stands on horizontal ground. Okay, at the point of 80 meter from the base of the pylon. Okay, the angle of elevation of the top of the pylon is 23 degrees. Calculate the height of the pylon to the nearest meter. Okay, so they say the electrical pylon stands on horizontal ground. So that means this one is your horizontal ground. Okay, this one is your horizontal ground. Then this one is your pylon. AB is your pylon, right? So they say angle of elevation is 23 degrees. So remember, elevation is looking up, right? Okay, so to the top of the pylon, okay? At the point of 80 meter from the base of the pylon, okay? So this is 80 meter from the base of the pylon, okay? The angle of elevation of the top of the pylon is 23. So can you see this is 80 meter from the base of the pylon? Okay, then when we say angle of elevation, which is the angle to the top of the pylon of A, so this is 23 degrees. So you need to understand what it means by angle of elevation. As I say just now, look up. Okay, look up. So 23 degrees, and you need to measure with the horizontal line. Okay, okay, so from the problems, we're able to draw this triangle. Okay, now what is the problems here? You need to calculate the height of the pylon. That means this is the height that you need to find. Okay, to the nearest meter. Okay, so for this one, we can solve using the trigonometry. Okay, so because we involve right angle 90 degree, and based on the angle of 23, so we know that tangent 23, which is equals to the height of the pylon AB divided by the base. Okay, the distance from the base, which is 80. Okay, then from here we can solve for the values of AB. So when we solve for the AB means 80 multiplied with tangent 23. Okay, then find the value for tangent 23 times 80, so you get 33.96. But the question asks for the nearest of the meter, so that means you can write it as 34. Okay? Okay, can you understand this problem? How it relates to angle of elevation? When come to your questions of tutorial, you will see the angles of elevation and depression again. Yes, Okay, so if you're okay with this example, okay, then before we move on to the area of the triangle, okay, so I give you a 10 minutes break, okay? Okay, then yeah. Okay, so I will mute the mic and off the camera. So I will see you after 10 minutes. So there's a timer here for you to refer. Then I will take the attendance. Okay, students, let's continue. Okay, so I will take the attendance. Today is lecture L4. From 3:15. Two hours lecture. Okay, take your attendance. Three absent. Four students. Okay, good. Okay. So let's continue. Okay, we've already done the angle of elevation and depression. Now we continue with the area of triangle. Okay. Okay, so here is to provide you the formula for the area of the triangle. I think when come to a right angle triangle, so we have no problems to actually get the area. Basically, we just take the half times the multiplication of two sides, so I can get the area of the right triangle. Okay. But how about the area of the triangles like the one that we have here for this one, right? Okay, so because when you look at this triangle, this is not a right angle triangle. I'm referring to the whole triangle. Okay, this is not a right angle triangle. So this one, none of the angle is 90 degree. So then how we actually going to solve the area of the triangle? Okay, if let's say for this triangle, we know the height, okay? So we know the height. So the height is of this triangle is actually measured from the base. Can you see this is a vertical height? When we say the height must be vertical height. So when we say vertical height here, this line must be 90 degree towards the base. Okay, then it's a vertical height of the triangle. So if we know this height and we know the length of the base, so for this triangle can be calculated by 1/2 times the base, okay, the b which is the base, times h which is the height. Okay, so we can calculate using this formula. Okay, so of course we also have other formulas for the area of the triangle, which is involve the angle and the length of the side. Okay, so we look at that later. Okay, so this is one formula. Okay, now this is another formula. Okay, and before we come to the formulas here, can you see the notations given here, right? There's a small letter, there's a capital letter. So I want you to take note, right? Okay, so when come to this triangle, can you see this triangle is not the right angle triangle, okay? It's not the right angle triangle. So when you deal with the triangle that is not a right angle triangle, then you can solve, you can evaluate, you can find the area of the triangle by using the formulas given here. Okay, but the triangle must have two sides. Okay, these two sides and the included angle. So what is means by the two sides and the included angle? Okay, now by looking at this triangle, right? Okay, first we look at the label. If you label this triangle as a ABC, we will using the capital letter to represent the vertices of the triangle, right? The 3 vertices of the triangle, capital letter. Then the opposite of the vertex A, right? Okay, we label it as a small letter of A. And this small letter of A is represent the length of this side. Okay, then come to vertex B, right? The opposite of the B, we label as a small letter of B, which is represent the length of this side. Then for vertex C, right, the opposite is the, we label as a small letter of C, which is the length of this side. Okay, so that's how we label the triangle. Okay, why is so important? Because the formula is follow this. Okay, if because last time for your previous group, I realized the students, because they label the triangle wrongly, so which when they apply the formula, they calculate wrongly. Okay, okay, now, so by looking at the area of the triangle, we only deal with ABC. If let's say the angle is ABC, we deal with ABC. Can you see here is ABC? Here is also involved AC, then will be B. Then we have ABC. Okay, so now the first 2 letter is a small letter. Okay, small letter means it represent the length of the side. And can you see we have sine C? So when come to sine, then you need to deal with the angle, the capital letter of the C, which is referring to the angle of the vertex C. Okay, the small letter of the A, B are referring to the length of the side. Okay, so this one, which is referring to this one. Okay, so half times AB multiplied with sine C. Okay, so here I already state clearly A, B, C, the small letter are the sides. Capital A, B, C are the angles. Okay, so if you want to find the area of the triangle using this formula, then you must have the length of 2 sides and the included angle. Okay, what is means by the included angle here? Can you see when we have a side of AB? So this is a side of AB. So by looking at this side and this side, okay, what is a included angle? The included angle is here. Okay, the included angle is the angle between the 2 sides. Okay, that is means by the included angle. Okay, so by applying this formula, you must have the 2 sides with the included angle. You cannot take the angle from others. Let's say you have side A and B. You cannot use the angle B. You cannot use the angle A to find the area. Okay, so which is wrong. Okay, that is not the formula. Okay, same things goes to okay, half of AC. Let's say you have the angle of A and also C, right? So by looking at the side of A and C, these are the 2 sides of the A and C, right? Then which one is the included angle? The included angle will be here. So that means this is involved B. Okay? Okay, then come to come to the other side of B and C. So B and C, which is referring to this one, B and also C. Okay, B and C, which is this side and this side. So the included angle is here. So which is A. Okay, so this is means by the 2 sides and the included angle formula to find the area of the triangle. Okay, so understand, right? How we applied the formula. Okay, later we will go through some examples. Okay, so I explain the formula first. Can you understand the formula, guys? Yes or no? Before I move on. Yes, the included angle most important. What is means by 2 sides and the included angle. Okay. Yes. Okay. Then I will move on. Okay. So now come to the sine rule and the cosine rule. Okay, so the sine rule and the cosine rule. Okay, let's look at the sine rule. So sine rule, we involve the angle, we involve the side. We can using sine rule to find the angle of the triangle or to find the length of the side of the triangle. We use this especially for the triangle that is not a right angle triangle without 90 degree. Okay, because with the 90 degree, normally we can solve by theorem of Pythagoras, we can solve by the tangent, sine, and cos. But when we deal with those triangle that is not a right angle triangle, we cannot using those theorem. Okay, we cannot using the tangent, sine, and cos. Then we have other rules for us to use, which is either a sine rule or cosine rule. So it depends on what are the values you have from the triangle. Okay, then to decide which rules to use. Okay, so now by looking at the sine rule, okay, according to the sine rule, again, the notations here is follow the notation I mentioned just now. Okay, so you have triangles of ABC, right? And this one is side A, side C, and the side of B. Okay, so this one is acute triangle, okay, because all the angle of the three vertices is actually less than 90 degrees, so it's an acute triangle. Okay, then we have another triangle given here, the shaded triangle. This one we call it as an obtuse triangle. So why we call it as an obtuse triangle? What it means by obtuse? Okay, I think just now there's a students posted some things about the terms of the acute triangle, obtuse triangle from Wei Huan. Okay, so obtuse triangle, obtuse angle, which is referring to angle more than 90, but less than 180. If we just say more than 90, not so accurate. It's more than 90, less than 180. More than 90, less than 180. So that means between obtuse angle is an angle that is more than 90, less than 180. Okay, so when we look at here, okay, so can you see this angle is already more than 90 degree, but is less than 180. Okay, so this is an obtuse triangle. Okay, now how we apply the, according to the sine rule is actually sine A divided by side A equals to sine B divided by side B equals to sine C divided by side C. So all these are the angle, and the one at the bottom, small letters, are the sides. Okay, angle and the sides. Okay, so for your information, instead of writing the sine at the top, the side at the bottom, we can also write the side at the top and the angle, the sine at the bottom. Of course, the rest you are going to write as this. Okay, so both also can be used, okay, because this one is actually same as this. Okay, and why I put the side on the top and the angle at the bottom? Because sometimes when we want to solve the problem, so if you want to find the angle, then will be more convenient if you put the sine on the top. If you want to find the length of the side, the ABC, the side, then it will be more convenient, easier to solve if you put the side on the top. Okay, just for the convenience. So it doesn't matter if even you want to solve for the side, you can also using this formula. Doesn't matter which one to use actually, just for the convenience only. Okay. Okay, then let's proceed. Okay, so the other rules is the cosine rule. Okay, cosine rules is involve three sides and one angle. Okay, so just now for sine rule, right? Okay, if we want to solve the problems using sine rule, okay, so we will sine A over sine B. Okay, so normally we will just involve two angles and two sides. Okay, so if you have one angle, if you have if you want to find the angle, okay, if you want to find the angle and you have the another angle and another two sides of the triangle, you can use sine rule. Okay, you can use sine rule. If you want to find the side, okay, to find the side, then if you have two angles and one side of the triangle, then you can using sine rule. Okay. And for cosine rule, okay, cosine rule, the formulas will involve three sides and one angle. Okay, three sides and one angle. Huh? Okay, when you look at the formulas here, a squared equals to b squared plus c squared, and then minus 2bc. So can you see this bc is actually come from here? Okay, minus 2bc and then cos a. The angle of the A is actually same as this one. This one is the side, but this one is the angle. Okay, so it's always corresponding. If let's say here is A, then here is A. If let's say here is B, here is B. But the B square is the side. The capital B here is the angle. Okay. So b squared will be equals to a squared plus c squared. Can you see a and c? Okay, minus 2a and c cos angle b. Okay, then for c squared is a squared plus b squared minus 2ab cos c. So this is the cosine rule. Okay, so when to use this formula, so it depends. So let's say you want to find a side. Let's say you want to find the side of c. Okay, then you have another two sides with another angle, the angle of the C, then you can use this cosine rule to find. Okay, so you must understand the formula quite clear so that when you are given a formula, a triangle, with some of the informations that you know about the triangle, then you know which formula you can use to actually find the answer. And of course, sometimes it's multiple ways to actually get the answer. Okay, sometimes you can using sine rule, you can using cosine rule, or sometimes you can only use cosine rule to solve, but not the sine rule. Okay, so let's move on for some of the example. Okay. Let me see how many. Okay, so our class until 5:15. Okay, let me go through two more slides. Okay. Okay, now let's look at this problem. So we are going to solve these problems by using what we learned just now, the sine rule, cosine rule, and also the area of the triangle. Okay, now you are given a triangle of x, y, z. So the angle x is 51 degree, angle y is 67, and side of YZ is 15.2 cm. Solve the triangle and find its area. Okay, now based on the information, let's draw the triangle. It would be easier for us to understand if we draw out the triangle. So let's say I label as X, Y, Z for the three vertices. And then the opposite of the X is the side X. The opposite of the Z is the side Z. And the opposite of the Y will be Y, right? Okay, so angle X is 51. Angle Y is 67. And the YZ, which is the X, so this is 15.2 cm. Okay? Okay, so these are the informations given. Okay, now, what is the requirement of the question? Okay, let me explain it here. Okay, can you see they say solve the triangle? What is means by solve the triangle? So, the meaning of solving the triangle means you need to find the angles that is not given just now. So can you see just now we already give you two angles and one side. So solve the triangle means you need to find the rest of the angle and the rest of the side. That is means by solve the triangle. So you already have two angles for x and y, means you need to find the angle for the z. You already have the side of the x, which is 15.2, so you need to find the side for the y and side of z. That is means by solve the triangle. Okay, so that means to find the angle of z, okay, and to find what is the length of z and what is the length of y. So the z, which is referring to xy, the length of xy, for y, which is referring to xz. Okay, so this is means by solving the triangle. Okay, so I think the first thing is we can try to solve the angle for z, because by with the two angles, then will be very easy to solve this angle. Okay, will be very easy to solve this angle z. Okay, as we know, the total internal degree will be 180. So we take 180 minus 51 and 67. So we get the angle of 62. So we managed to get z, the angle of z as 62. Okay, so done the angle. So next one, okay, I would like to find the side of the z and y. Okay, so how we find the side of the z and y? Okay, here we can solve using sine rule. Okay, so sine rule. Okay, according to the sine rule, okay, so can you see we have the side of the 15.2, right? So what is the angle, corresponding angle? So the corresponding angle is the angle x. So which is 15.2 over sine 51, the corresponding angle, right? 15.2 over sine 51, then is equals to what? Okay, then you need to find, let's say you want to find the side of y. So it's equals to y over sine 67. So can you see this is y? What is the corresponding angle? Which is 67 degree. And it's also equals to z over, this is z, the corresponding angle is here. And just now we obtained as 62, so over sine 62. So this is the sine rule. Okay, so from here we will solve for the y and z. So we can start with solving this one for the y, right? So 15.2 over sine 51 equals to y over sine 67. So if I solve it, that means y is equals to sine 67 times 15.2 over sine 51. Okay, and we get the answers of 80, okay, which is the length for xz. Okay, then next, okay, next we need to solve for the z. So again, we're using this one, right? So 15.2 over sine 51 equals to z over sine 62, and then we solve for the z. So which is sine 62 times 15 over 2.2 divided by sine 51. So I get the answer of 17.27 cm, okay, which is the length for the z, okay, xy. Okay, so I already find another two sides. So that means I solved the triangle already. Okay, I solved the triangle. Okay, before I move on, any question up to here? Is that clear?
No, ma'am, I have a question. Ma'am, why we are not applying cosine formula over here? Why sine?
Okay, so you say why don't use the cosine rule, is it?
Yes,
okay,
ma'am.
For me, right, to solve, okay, we have two rules to use, okay? If let's say both rules also can use, then I will prefer to use sine rule. Let's say both rules also can use, I will prefer using sine rule because easier to solve, right? By looking at the sine rule, it's easier to solve. Okay, so is these questions we can solve using cosine rule? Okay, now by looking at the angle we can solve by taking 180 minus 51 minus 7. Okay, so if using the cosine rule, is it possible? Okay, let us have a look. Can I solve using cosine rule? Say y. Okay, if I want to solve for the y, okay, that means I need, the formula will be y squared equals to x squared plus z squared minus 2xz cos y. So this is a formula, right? Okay. Okay. So now, do we have the x? Yes. But do we have the value for z? We don't have. Okay. So since we don't have the values of the z, then we can't using cosine rule to solve it. Okay. We can't use cosine rule to solve it. Is that clear?
Yes, ma'am. Thank you.
Okay. Okay. Now, let's move on to, okay, so for this case, we can't use cosine rule. Okay, so let's move on to the area. So the question also asks you to find the area. Okay, so for the area of the triangle, okay, can you see this one? We can't using the formula of half times base times height, because we don't have the height. So we have to solve using this formula, 1 over 2 AB sine C. Okay, so since we already have all the sides and all the angles, so that would be convenient for us to use this formula. So say we're using half times xy times sine z, xyz, half times x times y times sine z. Okay, so you just substitute the side of the x and y, okay, that we already obtained. So the x is actually 15.2. Then the y, which is 18. Then sine of z, so sine z, the z is actually 62. Okay, so half times 15.2 times 18 times sine 62. So you can get 128. Okay, okay, so since all the sides and all the angles are known, so we can also solve using the same formula but other way. Okay, we can involve another two sides and another one angle. For example, xz times sine y. Okay, or we can also solve by half times yz sine x. Also can. Okay, also can. Okay, so for half xz sine y, right? So you just substitute the x and z as a 15.2 and 17.27. Then the angle of the y, which is 67. Okay, then of course you should get the same answer. Okay, so is that clear? How to find the area?
Yes, miss. But I just have one question, miss.
Hmm.
To solve a question with the cosine, how many sides and angles do we need? Can you just repeat it?
Sorry, which rule?
The cosine rule.
Cosine rule,
Yeah.
Okay, to solve what? To solve the side or to solve the angle?
To solve the angle.
Okay, so to solve the angle, can you see if you want to use the cosine rule to solve the angle, let's say I'm using this formula. Okay, so the angle is this one, cos y. Okay, this is the only angle involved. So if you want to use cosine rule to solve for the angle, then you need 3 sides. You need 3 sides if you want to find angle. Okay?
Okay, MS.
But
and for the sides?
Okay, hold on. But if we're using cosine rule to solve for the angle, can solve, but can you see the cos y is here? So of course, it's a bit troublesome to solve this equation. Okay, so if you want to solve for the angle, if possible, we try to use sine rule because it's easier to solve using sine rule. Okay, it's easier to solve using sine rule. Okay, unless a sine rule can't able to use, then no choice, we have to use cosine rule. Okay, okay, then yes, what other question? Just now who is asking me? There's another question, is it? Or that's all?
That's all, miss. Thank you.
Okay. Okay, let me see the check box. Must have all sides to solve angle. Yes, okay. Okay. Then we move on to another example. Okay, this is another example. Okay, solve the triangle of the DEF. Okay, and find the area given that there are some information about the triangles. Okay. So for this triangle, okay, so just now the triangle, two sides are given, two angles given and one side given. So now this triangle, two sides are given and one angle is provided. Okay, so and we draw the triangle. So this is the angle and this is the two sides. Okay, now you need to solve the triangle. Okay, so can you remember just what I mentioned about solving the triangle? Okay, since you don't have another two triangle, so that means you need to solve these two triangle. Okay, so the requirement to get the angle for D and to get the angle for F. Okay, then after that, there's another one side here. So you need to find the length of the side E, or we can say DF. Okay, the length of DF. So these are the three things you need to solve. Okay, right now. So which one we can solve first? Okay, okay. So can you see we can solve the values of the E, the side of the E. Okay, why? Because I have two sides and plus one angle, and the angle given here must be corresponding to your side. Can you see the side you want to find is E, and the corresponding angle is the angle for E. Okay, then you can actually solve using cosine rule. Okay, so the side that you want to find is E, right? So we will use the cosine rule as E squared equals to D squared plus F squared, another two side, minus 2DF. So this one is a DF. Then cos E. As I say, this one must be corresponding. Okay, then substitute, okay, the D as 35, F as 25. Okay, minus 2 times 35, 25, then cos E, which is the angle 64. Okay, okay. Then now you try to calculate. Okay, so when we try to calculate, we able to get 1083. But please take note, the 1083 we obtain here is for E squared. So you want to find E, right? So you still need to get the square root of 1083, so which is 32.91 mm. Okay, so we managed to get the side of E, 32.91. Okay, now we need to move on to find another two angles. Okay, so to find another two angles, so is it possible that to using the sine rule? As I say, sine rule is easier to solve. Priority, we try to use the sine rule. Okay, so by using the sine rule, since you want to find the side, one side, right? One side, then you need another side and another two angles. Okay, so, okay, sorry, I want to find one angle. Okay, then you need another two side and another one angle. Okay, let's say we start with the angle F. So, which is the sine F. Okay, sine F. Then what is the corresponding side for F, which is 25. So you substitute 25 at the top. Okay, then since F is unknown, so another two values here you must be known, right? Okay, so we know the angle of 64. We know the angle of 64. So this one angle 64. Then we need the corresponding side. So this is E, right? The corresponding side is E. Just now we already found the E as 32.91. So we substitute here. Okay, then from here we solve for the F. Okay, we solve for the F. Okay, so how we solve for the f? Okay, so we can sine f is actually equals to 25 divided by 32.91 multiplied with sine 64. Okay, sine 64, which is 0.6828. Okay, okay. So now, as I mentioned just now, okay, you can also using this way to solve. Okay, if you're using sine rule, I can also write as this. Sine f over 25 equals to sine 64 divided by 32.91. Okay, so we can also write the sign at the top. So the f is unknown, right? Then will be easier for us to solve. So I can just write sine f equals to sine 64 divided by 32.91 times 25. This is what I'm trying to mean. If the unknown is f, right? So you just put the sine f at the top when you write the sine rule. So it will be easier for you to solve it later. Okay? Okay. So now, after you get the sine f equals to 0.6828, you haven't finished yet because you need to find the angle of the f. So to get the angle of the f, then you need to find arc sine. Okay? Students, do you know how to find arc sine? Okay? So if you, normally we will get the angle in degree. Okay? Then you remember to change the mode. Change the mode of the calculator to degree. Okay, change the mode of the calculator to degree to get 43. Guys, you all should try using your calculator. You know how to find the arc sine, right? Okay, so arc sine, normally you need to press the shift for the sign. Okay, you need to use the shift. Okay, now you already find the angle of the F. Okay, then for one last angle for D, you don't need to use a sine rule already. So we just use 180 degree minus 64 minus 43, then we get the angle of D. So easier to solve. We don't need to use a sine rule anymore. Okay? Okay, so we get all the angles, all the side. And the next one is to find the area. So find the area, you can use any of the side, any of the angle, because you have all the side, all the angle. So for example, we can use half times df sine E. Okay, half times df sine E. So just substitute the side of D, side of F, and then the angle of E. Okay, then we get the area. Okay, so is that okay so far? Any question? For your information, there are multiple ways to solve it. Okay, there are multiple ways to solve it. So when we start to discuss the tutorial questions, right, you realize that, oh, the way you solve and the way I solve is different. It doesn't matter. Okay, we have multiple ways to solve it. Okay, as long as you apply the rules correctly, then it's fine. Okay, different way is fine. Any question? Can, right? Okay. Okay, let me see. So for what we have gone through so far, you can actually solve many questions in the tutorial already. Okay, doesn't matter. Okay, the next two slides are actually quite simple. Then I would like to go through with you. Okay, So I think these are the last two slides for today's class. Okay. So this is about the conversion from the radian to degree. So just now students talk about your calculator. We should change the mode for degree and for radian. So what is the relationship between the degree and also the radian? Okay, we look at this slide first. Okay, so for your information, 360 degree is actually equals to 2 pi radian. Okay, 2 pi radian. So for pi radian will be equals to half of the 360, which is 180 degree. So this is a relationship between the pi radian and also the degree. Okay, so now, okay, sometimes we would like to convert the radian to degree, or from degree convert to radian. And how we going to convert it? So the idea of the conversion is actually come from this one. Okay, the 180 degrees equals to pi radian. Okay, now let's say you have a radian and you would like to convert it to degree. So how are we going to convert to degree? Okay, so you are going to take radian, okay, times 180 divided by pi. Okay, so in another words, I can also say I'm taking radian divided by pi, then I multiply by 180 degree in order to convert radian to degree. Okay, so how are we going to calculate it? For example, let's say you have 3 pi over 2 radian. Okay, 3 pi over 2 radian. So for the 3 pi over 2 radian, you divide it by the pi. Okay, divide it by pi. So because 1 pi is equal to 180, so you're taking the pi radian divided by pi, then you multiply by 180. So when you solve it, you can cancel the pi. So 3 over 2 times 180, which is 270 degree. Okay, 270 degree. Huh? Okay, then how about the 2.5 radian? Okay, so can you see this one? We don't have a pi. Huh? We have a radian, 2.5 radian. So the way to do it is the same. So we just take 2.5 divided by pi and then multiply by 180. So you're able to get 143.2 radian. So that's how we convert it. Okay. Okay. So now can you convert for me? If let's say I have 1.8 radian, what is the degree? What is the degree? (103.1). Okay. How you find? Right. Okay. So that means 1.8 radian, right? Okay. So it will be divided by pi. Then multiply by 180, so 103.1 degree. Right? Okay. Okay, next one. From degree to radian. Okay, from degree to radian. So since pi radian, 1 pi radian equals to 180 degrees. So the concept is like this. For the degree that you have, you multiply by pi over 180. So in other words, I can say I'm taking degree divided by 180, then I multiply by pi. Okay, so that's how I convert back to radian. Okay, so now if I have 30, so I take 30 divided by 180, okay, because 1 pi radian equals to 180 degree. So 30 over 180, then I multiply by pi radian. So I will get the answer as pi over 6 radian. Okay, sometimes for radian, we will remain the pi. Okay, or you can actually calculate the value. So you just use your calculator. Okay, take pi divided by 6, 0.524. Okay, so next one, if you have 60 degree, okay, 60 degree divided by 180 degree times pi radian. So which is pi over 3. You can write as pi over 3, or you can calculate in decimal. Taking the pi divided by 3, 1.047 radian. So this is just a simple calculation. Okay, so is that clear for you? Is that clear so far?
Yes, clear.
Yes, okay. So I think I already go through quite a lot, okay, today. So and tomorrow, wait, okay, we already done our classes, okay. I'm not going to see you tomorrow already. Okay, so your class Monday and Tuesday. Okay, then it's good. Actually, we have a lot of questions. So for what we have done today, you can practice the questions from number 2 until 20. Okay, practice question 2 to question 20. It's good that you have a one whole week, about a week, to practice this question. It's actually quite a lot of the question, and I think so some of the questions you really need to understand the scenario given here. Okay, then I will suggest you for this type of the questions, right? Draw out the triangle. Okay, draw out the triangle. So this one needs some understanding. Okay, draw out the triangle. Then you will be easier for you to understand the problem, then solve it. Okay, so I think the discussions of the next tutorial, we may need more than one tutorial class to get this question done. Okay, because it's quite a lot. So especially those questions are given in the problem, the scenario, right? All these questions, I think I will go through almost every single questions with you. Okay, but you need to try first, because you need to try to read the questions, try to understand and practice the question. Okay, so yeah, okay, so these are the questions you can practice by using all the sine rule, cosine rule, the formula for triangle, and ratios of the tangent, sine, and cosine to solve all these things. Okay, before we move on to the next part of the slides, for your information, the next part is regarding trigonometric identities already. It's another part of the trigonometric. Okay, but we try to get this tutorial done first before we move on to another part. Okay. Okay, so I think that's all for today. Any questions you want to ask before I dismiss the class? Oh yeah, so for today, right, just now the classwork, okay, for the classwork that, do we have any calculation just now? We don't really go through much just now. Okay, it's okay. I think nothing much to upload today. Okay, for tutorial, you don't need to upload first. Okay, next week we'll do the discussion. Even though you're already done, so you can check the answer with me, okay, because I will discuss. So just check your answer whether it's correct first. So after you confirm it is correct, if let's say wrong, you make the correction, then you only upload your work. So I think today, because most of the time is spent on the lecture, so nothing much you can upload. So I think that's all for today. Okay, no questions, right? Okay, then I will dismiss the class. Okay, so students, I will see you again on next Monday. Okay, so that's all. Bye, students.